Hello friends, once again welcome to chemistry classes by Vijay Kumar Sethi. We were discussing class 12th chemistry, the D and F block elements, and in this video we are going to discuss some properties of transition elements like magnetic properties, formation of colored ions, formation of complex compounds, catalytic properties, formation of interstitial compounds, and alloy formation. First come to the magnetic properties. When a magnetic field is applied to substances, mainly two types of magnetic behavior are observed, and these are diamagnetism and paramagnetism. And substances are known as diamagnetic substance and paramagnetic substance. Diamagnetic substances are repelled by the applied field, while the paramagnetic substances are attracted towards the applied magnetic field. Substances which are attracted very strongly are said to be ferromagnetic. In fact, ferromagnetism is an extreme form of paramagnetism. Many of the transition metal ions are paramagnetic. What is the reason? Due to the presence of unpaired electrons. Remember it. Presence of unpaired electron is responsible for the paramagnetic nature of any ions. Okay. The magnetic moment is determined by the number of unpaired electrons and is calculated by using spin-only formula. This is mu. This is magnetic moment is equal to square root of n plus 2 bm, where n is the number of unpaired electrons and this bm, that is Bohr magneton, this is the unit of magnetic moment. A single unpaired electron, it means if n is equal to 1, then it has magnetic moment of 1.73 Bohr magnetons. Yeah, it means if we know the magnetic moment, we can find out the number of unpaired electrons. Formation of colored ions. Most transition metal ions are colored due to d-d transition of unpaired electrons. Now, what is the meaning of this d-d transition? In the presence of ligands, 5 d orbitals will split into two categories, that is T2g and EG level. Okay, and that's why we will get the two set of d orbitals. Electron from lower d orbital will excite to the higher d orbital, and this is called d-d transition of unpaired electrons. When an electron from a lower energy d orbital is excited to a higher energy d orbital, the energy of excitation corresponds to the frequency of light absorbed. This frequency generally lies in the visible region. But whatever the color we observe, and this color observed corresponds to the complementary color of the light absorbed. Is it clear? See from this table, when if violet light is absorbed, then we will observe the yellow green color. Okay, same if anything is visible as a purple, it means that thing absorb green wavelength. In the same way, if anything is observed as blue, then we can say that thing has absorbed orange color wavelength. Like green plants are green because they absorb the purple light of 720 nanometer wavelength. Okay, so these are the color absorbed by the substance, and these are the color observed, which is the complementary of this one. The frequency of the light absorbed is determined by the nature of the ligand. Okay, more detail of ligand we will discuss in the next chapter, that is coordination compound or coordination chemistry. In aqueous solutions where water molecules are the ligands, the colors of the ions observed are, you can say, these are the color given by some ions, and you can say this picture also show these colors. Like if we are having V4 plus, this is blue color. You can say from this table V4 plus is blue, V3 plus is green, then Mn2 plus, this is pink, Fe3 plus, this is yellow. Okay, this is cobalt 2 plus and cobalt 3 plus, these are the blue pink. Cobalt 3 plus is 3d6 and cobalt 2 plus is 3d7. The same way Ni2 plus, this is green, and copper 2 plus, this is blue in color, and this is their electronic configuration. Is it clear? Formation of complex compounds. The transition metals form a large number of complex compounds. And why? This is due to the comparatively smaller size of the metal ions, their high ionic charges, and the availability of d orbitals for bond formation. Few examples of these complex compounds. These are also known as the coordinated compounds or coordination compounds, like FeCN6 3 minus, FeCN6 4 minus, CuNS3 4 2 plus, PtCl4 2 minus. Complex compounds are those in which the metal ions bind a number of anions or neutral molecules, giving complex species with characteristic properties. Catalytic properties. The transition metals and their compounds are known for their catalytic activity. Reason is, this activity is due to their ability to adopt multiple oxidation states, that is more than one oxidation state, variable oxidation state, and to form complexes. Some examples like vanadium 5 oxide, vanadium pentoxide, this is used in contact process. Finally, divided iron, this is used in Haber process, and nickel, this is used in the catalytic hydrogenation. These are some example of catalyst. For example, iron third catalyze the reaction between iodide and persulfate ion. See, this is the overall reaction. This is iodide ion, this is the persulfate ion, and these are the products, iodine, and this is sulfate. Now, an explanation of this catalytic action can be given as, in this case, we can say this Fe3 plus is acting as a catalyst. First of all, this react with the I minus, and this will convert into Fe2 plus, and I2 is formed. Then this Fe2 plus react with the persulfate ion, and again the regenerate this Fe3 plus. This is a catalyst. This is a regenerate. Okay, and sulfate is formed. In this way, catalytic activity is shown by these metal ions. Formation of interstitial compounds. Interstitial compounds are those which are formed when small atoms like hydrogen, carbon, or nitrogen are trapped inside the crystal lattices of metals. They are usually non-stoichiometric and are neither typically ionic nor covalent. For example, TiC, Mn4n, Fe3H, VH0.56 and TiH1.7, etc. The formulas quoted do not correspond to any normal oxidation state of the metal. Because of the nature of their composition, these compounds are referred to as interstitial compounds. The principal physical and chemical characteristics of these compounds are as follows. They have high melting points, higher than those of pure metals. They are very hard. Some borides approach diamond in hardness. Borides means if a boron is trapped, then that is called boride. They retain metallic conductivity. They are chemically inert. Alloy formation. As you know, what are alloys? These are the homogeneous mixture of metal with another metal or metal with non-metal. These are the alloys. Alloys may be homogeneous solid solutions in which the atoms of one metal are distributed randomly among the atoms of the other. Such alloys are formed by atoms with metallic radii that are within about 15% of each other. Clear? We can say there should not large difference between the atomic radii. And again, we have discussed that in transition metals, the difference in the atomic radius is less. That's why these metals can mix into each other and they can form alloys. Because of similar radii and other characteristics of transition metals, alloys are readily formed by these metals. The alloys so formed are hard and have often high melting points. The best known are ferrous alloys, in which iron is a main metal and this is mixed with the another metal like chromium, vanadium, tungsten, molybdenum, and manganese are used for the production of a variety of steels and stainless steel. Alloy of transition metals with non-transition metals such as brass. Copper is a transition metal while zinc is not a transition metal. Okay, this is composition of brass, copper and zinc. Bronze, copper is a transition metal but tin is a p block element. Okay, are also of considerable industrial importance. Now see some examples. Why does V2O5 vanadium pentoxide acts as catalyst? V2O5 acts as catalyst because it has large surface area. It can form unstable intermediates which readily change into products. Or we can say it also shows the variable oxidation state. Of the ions CO2 plus, Sc3 plus and Cr3 plus, which one will give colored aqua solution and respond to magnetic field? Again remember, any substance is colored, it means that ion or ions present in that substance must have unpaired electrons. At the same time, if that is paramagnetic, same reason, presence of unpaired electron is responsible for the paramagnetic nature. You can write the electronic configuration of these ones, Cu2 plus, Sc3 plus and Cr3 plus. If you write the electronic configuration, then you can find out unpaired electrons are present or not. So you can say CO2 plus and Cr3 plus are colored and attracted in magnetic field because they have unpaired electrons. Whereas Sc3 plus scandium does not have any unpaired electron, hence it will be repelled by magnetic field and its solution is again not colored. It will not give color. Okay. Next, scandium forms no colored ions and yet it is regarded as a transition element. Again remember, any substance form colored ions due to the presence of unpaired electron. Okay, but we can say that is and transition element is that element which has incompletely filled d orbitals either in the elemental state or in any its ions. So we can say this scandium has incompletely filled d orbital. That's why it is regarded as a transition metal, but it forms no colored ions due to the absence of unpaired electron in Sc3 plus. Sc3 plus has noble gas configuration, no unpaired electron. That's why it will not form any color or not will give any color. Again, give reasons for the following features of transition metal chemistry. Most of the transition metal ions are colored. We already discussed that is this is due to the presence of unpaired electrons, and these unpaired electrons undergo d-d transition by absorbing light from visible region and radiate complementary color. Transition metals are well known to form complex compounds. This is due to small size and high charge of cation and presence of vacant d orbitals. The second and third members in each group of the transition elements have very similar atomic radii. Okay, if you remember, this is due to lanthanoid contraction. Dear student, subscribe my channel to get the next video about lanthanoids. Thank you.